Hello, in this video we're going to learn about the rules for resistors in a parallel connection. Recall the rules for current and voltage in a parallel connection. Yes, the current is additive in a parallel connection, however the voltage is equal across each component in this parallel connection. Let's refer to Ohm's law. The voltage is equal to the resistance multiplied by the current. And let's take the case of a battery with two resistors connected in parallel to this battery. Then the current, I total, which is the current of the circuit, is equal to I1 added to I2, where I1 is the current across the first resistor and I2 is the current across the second resistor. And using Ohm's law, U is equal to Ri, and by rearranging this law, the current is equal to the voltage divided by the resistance. So let's replace each term by its expression. I total is equal to V total divided by R total, which is the total resistance. I1 is equal to the voltage divided by R1, and I2 is equal to the voltage divided by R2. Replacing them, the equation will be V divided by R total is equal to V divided by R1 plus V divided by R2. And since the voltage is equal in a parallel connection, then we can divide this equation by V in order to get the equation for resistors in parallel. 1 divided by R total is equal to 1 divided by R1 plus 1 divided by R2. So, the total resistance of two components in parallel connection will be less than the resistance of the resistor with the least resistance. And adding more resistors in parallel will decrease the total resistance. This is because the total potential difference is the same across each resistor. So, adding an extra resistor in parallel increases the total current entering the combination. Because the total resistance is equal to the battery potential difference divided by the total current entering the combination, well, let's focus on this point. The total resistance is equal to the battery potential difference divided by the total current. How is that? Let's recall Ohm's law. The resistance is equal to the potential difference divided by the current. So for the total resistance, we're going to take the total potential difference that is supplied by the battery, so it's the battery potential difference, divided by the total current. Why have we used the total current? Because in a parallel connection, the current is additive. So we should take the total current, that is the summation for the current passing in each component. So the total resistance is equal to the battery potential difference divided by the total current entering the combination. The total resistance is less than it was before the extra resistor was added.